Hello, nice to be back here. Today I'm going to try to talk about how we are using Zabbix in a Devops environment at the University of Oslo. At the University of Oslo we have different groups of developers. They are in charge of different web applications and APIs. These applications are used for administration tasks, but also by many research groups at the university. And some of them are used outside the university by other educational institutions around the country. About 2 years ago, some of the developers contacted us and they needed help to monitor all these web applications. They were trying to implement a DevOps environment where they could work in a better way, and they were missing the monitor part of the process. What we did is we started talking with them, and in the first meeting we had with them, they told us that they wanted to, of course, monitor these applications, that they didn't have time to learn another monitor system, and that they wanted to also monitor not only the web application if it was running and available, but also all the components the applications need to work. What we told them is that we could help them to automate this process, but we needed some kind of standardization to do this. And what we learned in this process, helping them to get what they needed, was that you really have to listen to each other to understand the problem and to try to find the best solution. You need to cooperate and to work as a team. This is even more important than listen to each other. You need standardization. When you find out a way of doing something, you have to do it in that way, and everybody involved in the projects has to follow the standard. If not, it won't work. And of course, you need full automation of many of the processes involved. This is especially important in a DevOps environment, and this is what we wanted to try, full automation of when we were monitoring these applications. We have some challenges. The first one is that we didn't know where these applications were running. We didn't know the servers involved in the process. It's a very dynamic infrastructure. We don't have a central place where we register the servers running all these applications. Last time I checked, we have almost 90 servers involved in the process. We didn't know the applications out there. Nobody has a full overview of things running in the systems. Again, we don't have a central register with all the applications we are running in our systems. And in addition to this, we have production and test and development versions of all these applications. We needed different alarm levels depending of the type of application we are talking about. And the last time I checked, we have around 60 applications running in our systems. These applications have one or more multiple instances, and these instances can be run in one or multiple servers. And we do this for the redundancy and for performance. Again, no central register with information about the instances running out there. The applications have components they need to work. A component can be a database or API or whatever. The different systems needed for the application to work. And we wanted to monitor also these components. But we wanted to do it from this application side, because the site really knows if a component it needs is available or not. And again, we wanted to have also possibilities of having different alarm levels for the different components, because not all of them are equally important. And we needed also to know who owns or is in charge of these applications, because we needed to know who to contact when something happens with the applications, and we needed to send notifications to the people in charge of the application. So we have a very dynamic environment, and nobody has a full overview of the things happening around. We wanted to use the functionality and the systems we have. So we used the Zabbix API for the configuration of Zabbix. We used the auto-discovery functionality in Zabbix to find out all the instances and components all applications need. And we use a system called Nilheim as a data source for the automation. Nilheim is a system that we have developed at the University of Oslo, where we run Nilheim agents in all the servers in the infrastructure. And these agents will get some configuration and system information in the server, and will send this information to a central database where we can use to search via an API or a web console. So it's a great tool for automation, and we use it in many places. What we found too is that we needed some help from these applications to get the automation in place. And then the developers told us that we have full control of the code. So what we can do is that every instance running in a server can generate what we call a health file with information about that instance. That file will have some metadata information on the top, with information with the name of the application, with the name of the instance, where we can find out that application, who owns the application, and so on. And it will have information about all the components needed by the application, if the component is present or not, and what kind of level, the alarm level we are going to use if the component is not working. And this health file, it was the only thing we needed to start automating the system. With this health file in place, we could find out and identify the servers running applications. We use our configuration manager to do this. We can find out all the servers with health files in the system, and we will register these servers in our central Nilheim database. With all the servers identified, we can start configuring Zabbix. What we did to configure Zabbix was this. We have all the servers running these web applications. We have Nilheim, is our central database, data source with the information we need to automate the server, Zabbix. We have our Zabbix installation that we have to automate and to configure. And we have a management server where we run our automation scripts. As I say, we have these health files around in all the different servers running applications. What we do is we run a script that will read these health files, and then it will extract all the metadata information in the file and the components the application needs. And it will save this information in a Nilheim database. When we have done this all over the place in all the servers running applications, we will start our automatic our script that starts the automation. These scripts will read information from Nilheim and will do two things. The first one is that it will find out all the applications running all over the place, and it will create a host in Zabbix for every single application in the system. It will also create a user macro for every application with information where the application is running. And it will link a template that we need to define what we are going to monitor. The other thing that this automation script will do is to generate some JSON files with auto-discovery data that Zabbix will use to find out the instances and components an application has. And in this moment, we have Zabbix configured with all the applications we have in the system, and everything is ready to get monitoring data. So that's what we have to do. We have to collect the data we have in all these servers. And here comes the tricky part, because Zabbix doesn't know where all these applications are running. We know the applications that are out there. We know the components and the instances every application has, but we don't know where they are running. So Zabbix cannot ask the servers to get the specific information. What Zabbix does and knows is that the servers out there know what they are running. And then what we do is the following. We have two templates in Zabbix. The first one, we link it to all the application hosts in Zabbix. And the second one, we link it to all the servers running applications. The template linked to the application host will use the auto-discovery data we have generated to get information about all the instances and components an application have, and it will generate all the items and triggers an application will have. And when that is in place, what we will do to start the collection of data is to use the template linked to the servers running applications, and this template will use the Zabbix agent in every server. The Zabbix agent via the user parameter will start a script that will read all the health files that we have out there. And that script will find out all the instances and components and the status of these components in that server, and will generate the information needed by the Zabbix sender process that, or software that we get via the Zabbix core. And that Zabbix sender have information of the web application and the instance and the component and the status of that component. And it will send the data in to the server and it to the right application host. So every host can get data from multiple servers and without knowing where the application is running. And the result of this is that we get web monitoring of all the applications we have around. We have also monitoring of all the instances and components that application need. We have different levels of severities depending of the component, type of component, and depending on the type of application, if it's a production, test, or development. And the best of all is that everybody is really happy. The system is very stable. We have a system that automatically finds out what is happening out there. We have a system that finds out new applications when they come, that delete all applications where they are gone, and a system that also dynamically finds out all the components an application needs to work and monitor them. And yeah, this is actually all I have time to say. Any questions?
Yes. Questions from Slido, please.
The first will be, is your self-developed system is an open source project? If not, do you have a plan to release it?
Good question. Until now, it's been a close project for the university, but now we have almost ready the first version that we are going to make available for everybody as an open source. We are just working with the last details to do it, so it gets more easier to use and to install to people out there. So it will not take long until the Nilhamn is available for people if they want to use it.
Why do you call a script from a Zabbix agent to send the data using Zabbix sender instead of using like a cron job or something else?
Well, you can use a cron job to run these scripts too, but it needs more maintenance. If you run things via cron, you have to have a system to manage and to administrate all these cron jobs, and it's much easier just to tell the Zabbix agent do this, and the Zabbix agent will be able to run all these jobs, and at the same time to get a return code that you can send back to Zabbix to know if it's running well or not. If you do it with cron, you will have to monitor too if cron is running, if all the cron jobs are running, and so on. So it's easier to administrate, more effective.
And what do you use for Zabbix redundancy?
For Zabbix redundancy? What do you mean with in which?
It's a question from Slido, sorry.
Okay.
High availability.
High availability? We have, right now what we have is all the web servers. We have several web servers via load balancing, so we have redundancy in that part. The Zabbix server and the Zabbix database, we move it to physical server not long ago, and we don't have any redundancy with this in the software level, but we have a lot of redundancy in the hardware level. And we have extra hardware ready to take over if it's necessary. And the rest, all the proxies we have, they are running in virtual machines. So if we need new ones, we just create them, and in a couple of minutes we'll have a new service available. So we don't have a 100% full automatic redundancy, but in just a few minutes we have the system up and running.
Okay. Yeah. Okay. So you mentioned that effectively on working on some Zabbix description, in the middle you are using just some JSON files.
Yes.
With some kind of a description. So effectively you are using some kind of a stage of provisioning some resources. What do you think about just not holding all those informations in a JSON file, but in a kind of a dynamic and extended inventory, resources, and processing those informations, injecting in an inventory, and on the next stages using those inventory information to, let's say, add exact templates, or even obtain information about exact state of some resources,
right,
or, managed on an exact host or our application.
Right, but that's what in a way we are doing with Nilhamn, because what we are doing is we are using the central Nilhamn database in a way as a, it's not inventory, but it's we can.
It's like.
Yeah, but we can search all the information that we automatically send.
But if you will have an inventory in a Zabbix as a database, you can still search it.
Yeah, two. Yeah, but we don't have a central inventory.
Yeah, but it will be possible to use this database
of
for
course.
many different
Yeah,
things.
Oh, yeah, of course, it will be possible. Yeah, and if you have
I'm still have just on the back of my head this kind of idea about a complete dynamic just inventory, not just with static set of list of type of items which you can inject about application A, application B, location, licenses of whatever. Yeah, but add my own field like a version of the Zabbix agent and. Looking on the inventory, I want to see just, let's say, how many hosts has the exact version of the Zabbix agent over inventory, straight.
Right. But as I say, that we do that with that Nilheim system. And we started using that, we did this system because we didn't find an inventory system out there that was right for us, that it did all the things we wanted to do. Because we use it also for other things, not only for Zabbix, but we can send automatically a lot of data in and
use this for over API for all the applications.
Yeah.
So as we are running a little bit out of time, thank you very much, and you will be able to ask your questions during the coffee break.